Hello students, here we are going to discuss about classification of pipelining or pipeline processors. So according to Handler's classification, based on the level of processing, the pipeline processors are classified into three types. First is arithmetic pipelining, second is instruction pipelining, and third is processor pipelining. So first we'll consider arithmetic pipelining. So what is arithmetic pipelining? So here the arithmetic logical units of a computer can be segmented for pipeline operations in various data formats. Arithmetic pipelining constructed for simple fixed point and complex floating point arithmetic operations. And these arithmetic operations are very well suited to pipelining as these operations can be efficiently partitioned into subtasks. Example, star 100. So we can give the example of fixed point adder as well as floating point adder. If we consider the floating point adder, which consists of 4 stages. So these 4 stages are nothing but, first we are going to compare the exponents, then equalize the exponents, adding the mantices or adding the fractions, normalizing the results. So these operations are assigned to S1, S2, S3 and S4 respectively. And these stages are pipelined in case of arithmetic pipelining. Coming to the instruction pipelining, the execution of the stream of instructions can be pipelined by overlapping the execution of current instruction with fetch, decode and operand fetch of the subsequent instructions. So it is also called instruction look ahead pipelining. So this is the figure representing the instruction pipelining, which represents overlapping of the execution of the current instruction with instruction fetch, decode and operand fetch of the subsequent instruction. Third is processor pipelining, which refers to the processing of the same stream by a cascade of processors, each of which processes a specific task. So data stream passes the first processor with the results stored in a memory block, which is also accessible by the second processor. Second processor then passes the refined results to the third. So this is the example of processor pipelining, diagram representing processor pipelining. First processor accessing the memory block, so which is given to the processor 2. Processor 2 gives the refined results to processor 3 and so on. Then next we'll consider the classification according to Lee and Ramamurthy. According to pipeline configuration and control strategies, Lee and Ramamurthy suggested the classification of pipeline processors into three categories. First is unifunction versus multifunction pipelines. Second is static versus dynamic pipelines. Scalar versus vector pipelines. Unifunction means single function, multifunction means multiple functions are performed by the pipeline. Static, only one function is performed at a time. Dynamic means multiple functions are performed at a time. Scalar, as indicated by scalar operations performed by the pipeline. Vector pipeline means vector operands are performed by the vector pipelines. So then what do you mean by unifunction versus multifunction pipelines? A pipeline unit with fixed and predicated function is called unifunctional. Example, Cray1. It has 12 unifunctional pipelines which are distinguished under 4 groups. Address functional units consisting of address add unit and address multiply unit. Scalar functional units consisting of scalar add unit, scalar shift unit, scalar logical unit and leading zero count unit. Vector functional units consisting of vector add unit, vector shift unit, vector logical unit. Floating point functional units consisting of floating point add unit, floating point multiply unit and reciprocal approximation unit. Coming to the multifunctional, a multifunction pipe may perform different functions either at the different times or the same time. So this can be done by interconnecting different subset of the stages in pipeline. Example, TIASE. Next, we'll consider static versus dynamic pipeline. Static pipeline, it may assume only one functional configuration at a time. Static pipelines are preferred when the instructions of the same type are to be executed continuously. A unifunction pipe is considered to be static. Dynamic pipeline, it permits several functional configurations to exist simultaneously. A dynamic pipeline must be multifunctional. A dynamic configuration requires more elaborate control and sequencing mechanisms than static pipeline. Coming to the scalar versus vector pipeline. Scalar pipeline processes a sequence of scalar operands under the control of do loop. The instructions in a small do loop are often prefetched into an instruction buffer. The required scalar operands are moved into the data cache to continuously supply the pipeline with the operands. Example, IBM system R360, model 91. Coming to the vector pipelines, they are specially designed to handle the vector instructions or vector operations over vector operands. The computers having vector instructions are called vector processors. The design of the vector pipeline is expanded from that of the scalar pipeline. Handling of vector operands in vector pipelines is under firmware and hardware control. Example, Craven. So all these are about the classification of pipeline processor. So first category, which consists of arithmetic pipelining, processor pipelining, instruction pipelining. Arithmetic pipelining, where the arithmetic logical units can be segmented for the pipeline operations in various data formats. Example, floating point adder. Different stages are exponent comparison, exponent equalization, mantissa addition, then normalizing the results. So these stages are overlap with one another. Second is instruction pipelining, in which the execution of current instruction is overlapped with fetch, decode and operand fetch of the subsequent instruction. Processor pipelining, in which it is a cascade of processor. The first processor with the result stored in a memory block which is accessible by the second processor. Second processor refines the results and passes to third. Again third passes the results to fourth and so on. According to the pipeline configuration and control strategies, they are classified into unifunction versus multifunction. Unifunction performing fixed dedicated function, whereas multifunction pipe may perform different functions either at different times or at the same time. Static versus dynamic. A static pipeline may assume only one functional configuration at a time. Dynamic pipeline processor permits several functional configurations to exist simultaneously. Scalar versus vector pipelines. Scalar operations which are performed by scalar processors. Vector pipelines which perform vector operations over the vector operands. Thank you.